What's up everybody, I'm Wallace and you're watching A3Academy. Today we're going to be talking about Newton's first law of motion. So in 1687, Isaac Newton came up with these three laws of motion, and the first law said that an object will remain at rest, or move at a constant velocity, unless there's a net force acting on the object. So suppose you had an object in outer space, and that object was at rest, so basically that means that the velocity is equal to 0. Since there are no forces acting on the object in outer space, the object will continue to stay at rest until acted on by some unbalanced force. In the same way, suppose you had an object moving at a constant velocity, like say 5 meters per second. Since there are no unbalanced forces on the object will continue to move at 5 meters per second until some unbalanced force acts on the object. Now remember, since velocity is a vector quantity, a change in direction means a change in velocity. If we shoot a space probe out of Earth and into outer space, it'll continue to move at that velocity until it interacts with another object in outer space. Since there aren't many objects that could impart a force on the spacecraft in outer space, the space probe will continue to move at the same speed in the same direction for a very long time. The Voyager I probe, which was launched in 1977, is still moving at the same speed that it was 30 years ago, without using any fuel. Since virtually no outside forces have acted on it, it'll keep continuing in the same velocity. So that's basically Newton's first law of motion. Alright, you might be thinking, but why are more massive objects harder to move? Well, that brings us to Newton's second law. I'll be making a video on Newton's second law very soon, so stay tuned. But for now, be sure to subscribe to our YouTube channel, like us on Facebook, and follow us on Twitter. And as always, the more you know, the better you are.